In this video, I will go over examples from section 10.2. In the previous video, I talked about how the central angles that form an entire circle add up together to equal 360. So in this example here, this angle right here is 130 degrees. This angle right here is 90 degrees. And these three angles together add up to 360. So we can make the equation that 130 plus 90 plus x equals 360. And then we can solve for x to get 140 degrees. In this investigation, you are supposed to look at the relationship between the degree measure of the arc and the central angle. So notice that this red arc is the intercepted arc inside of the central angle. The blue arc would be the rest of the circle. And hopefully you found that the central angle and the arc measures were equal to each other. So in this question, we're trying to find out if GH, so this arc right here, is a major arc, a minor arc, or a semicircle. Well, because it's two letters, it has to be a minor arc, which means it's less than 180 degrees. And this is the central angle for GH, since it's circle K, and K is the center. So the degree measure of arc GH is 122 degrees. Notice the little M in front of the name of arc GH. Anytime you see that, that's asking for the degree measure of the arc, not the length. Congruent arcs in the same or congruent circles are going to have the same measure of each other. Now, this is not true of arcs that are in two different circles that are not congruent. Even if their degree measures are the same, their lengths would not be the same, and so they would not be congruent. So this is only true for arcs that are in the same circle or congruent circles. So in this case, if angle 1 and angle 2 in this picture are congruent, then their intercepted arcs JH and FG are also congruent to each other because they're in the same circle. And vice versa, if the arcs are congruent, then those angles are going to be congruent. When making pie charts, what happens is someone takes some data, so has a total number of people that they've asked a question. So in this particular case, girls were asked what sports they play. And then they took that amount of people that played basketball, for instance, and divided that by how many people were asked and got that 20% of the people answered that they played basketball. So in order to make the pie chart, we need to know these angle measures, these central angles, and then also these arc measures. Well, this is 20% of the whole circle. So that means this angle here is 20% of the 360 degrees. So if I'm trying to find the measure of CD, CD is going to be 18% of the 360 degrees. And to find out what that is, we take 0.18 and multiply it by 360 to get 64.8 degrees. Then we notice that this one is 18% for CD. BC is also 18%, so we know that those are congruent arcs and they have the same measure. finally, just like the segment addition postulate, the angle addition postulate, arcs work the same way, that when you have two arcs that make up a big arc, those two arc measures are going to add up to equal the measure of the big arc. So in this example here, if I want to find the measure of AED, that's this arc right here, I know that this piece is 63 because it's going to be equal to that central angle. This piece is 90, and we can add those two together to get 153 degrees. For arc ADB, we start at D, come all the way around, we start at A, come around to D, and go all the way to B. Now here, we have to notice, since this is circle F, that BE is a diameter and is 108, makes this semicircle of 180 degrees. This piece is 180. That semicircle is 180. This piece we already knew was 63. So the whole thing would be adding those two together, or 243 degrees. Now, to find the length of an arc, we have to use a proportion. Our proportion is going to be made up of two kinds of ratios. We're going to have a ratio of degrees and a ratio of lengths. Also, with our degrees on the top, our degrees and lengths on the top, we're going to have that arc, or part of the circle. And on the bottom, we're going to have the whole circle. So for degrees, here we would have the central angle measure, which is also equal to the arc measure. And here we're going to have the degrees of the whole circle, which is 360. For lengths, we're going to have the arc length, which is the part of the circle, and then the length of the whole circle, which we call the circumference, which is 2 pi r, or pi times the diameter. So I would suggest using this proportion anytime that you have a problem that involves arc length, for two reasons. It's easy to remember because it makes sense. They're two ratios that are related to each other. One is a degree ratio, one is lengths ratio. And no matter what you know, you can plug those things in and then find the thing that you're looking for. So while they do also give a formula here, I would use this proportion every time rather than the formula. So in this case, you'll notice that they're asking for the length of arc ZR. That's how you know that they don't want the degree measure, they want the length, and that you need to use the proportion. So if we set up the proportion, we know that the central angle for arc ZY is 130. The whole circle is 360. The arc length is what we're looking for. And since the diameter is 10, the circumference, or the distance around the entire circle, is 10 pi. Then we can cross multiply to get approximately 31.4 centimeters for the length of arc YZ.